Hi, welcome to the Retirement Railroad Matinee Modeling Tip of the Day. I'm Steve, and you can blame this tip of the day on Heath. All right? Not really. Last Monday, this is Friday, last Monday or Tuesday on one of his live streams, he was comparing plastic versus metal wheels. And there's probably hundreds of videos out there doing this comparison. What made Heath's better than any of the ones I've seen previously is somebody had mentioned using an AccuTrack speedometer to record the speed differences between a plastic wheel set and a metal wheel set. Okay, and you use 3 different box cars. Okay, and so and had some great results. So then he added some weight and measured the effects, and the problem starts to happen there. And he, of course, said, okay, not all things are equal anymore, and blah, blah, blah. Well, you know, although I born in Iowa, grew up in Illinois, you know, Tall Corn State, land of Lincoln. Both my parents came from Missouri, all right? And for those that don't know, the state slogan of Missouri is "Show me." And a lot of that mentality has transferred over to me. So I want to understand why things are differently. And it's very easy in this case. Okay? It's simply a matter of physics. Having an engineering background and taking a multitude of physics classes 40 plus years ago, so I've forgotten more than I remember, but at least I remember the principles. Okay? So with that, let's take a look at some of the science behind plastic versus metal wheel sets, weighted, unweighted, etc. All right, and it boils down to the laws of physics. All right, and like I say, we can get into a number of different laws of physics. You know, Newton says basically the first, second, third, all fall into the same thing. If an object's in motion, it'll stay in motion until another force acts upon it. Okay, and that force in the case of wheel sets is friction. Okay, now where does friction come from? The force acting upon the rolling, when you roll wheel sets down an incline, such as in Heath's experiments, such as in the or demonstration, such as the demonstration I'll show you here in a minute, the force acting upon it, making it roll, is gravity, and the force of gravity is 32 feet per second, or 32 feet squared, okay, per second squared. That's the force making it roll. So as it comes down the incline, it makes it roll, and it should stay in motion forever, except for friction. Okay? Now, in Heath's experiment, and you'll see it also in my demonstration, is the plastic wheel sets are not moving as fast at a given point at the bottom of the incline as compared to the metal wheel sets. Okay? And that's due to the difference in friction acting upon those trucks and wheel sets. Now, you have a number of different points. In the 40-foot box car example that Heath uses, you have not only the points between the plastic wheels and rails, all right, metal rails, you also have the plastic axles versus the plastic truck pockets. Right? And those are actually create more friction than the wheels rolling. All right, there's less resistance to the wheels rolling than there is to the axles spinning in those pockets. All right. Now the coefficient of friction. There's a simple formula. We can get into the formulas. You know, I've got them down here, and I got Newton's laws down here, gravity, blah 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 blah. All right, and the force, mass. Okay. Force equals mass times acceleration, where acceleration is gravity. Okay, 32 feet per second. Okay, that's acted upon by the mass. Now, you know, all things being equal at the same weight, the only difference becomes that friction, and there's a coefficient, what's called a coefficient of friction, between two surfaces. Okay, as an example, plastic to plastic has a coefficient of friction, and granted, there's different types of plastic, I know, and then you can polish them and lube them, and, you know, graphite, etc., but let's just deal with the basics, okay? Plastic on plastic is about 0.8, all right? Nickel on nickel, unpolished, is 0.7. Therefore, the coefficient of friction, there will be less friction, everything else being equal, with metal than there is with plastic, and thus metal wheels roll better. It's that simple, all right, from a scientific standpoint, all right, all things else being equal. Now, that means all the pockets being the same, axles being the same, etc., etc., etc. Once you throw another variable into it, things change. For instance, we throw added weight on a car. Now, weight has a how do I explain this? You know, I've gone through 10 reiterations of this tip of the day, trying to keep it understandable but simple. Weight is increasing the mass. Still the same acceleration from gravity at 32 feet per second. You have the same coefficients of friction. But because you have more weight, there is more friction when you multiply it out, okay? Which reduces the force, the resultant. Well, it increases the force down, all right? But the coefficient of friction will make it stop in a shorter distance at the same velocity to start with. Now, in my demonstration, you're going to see a center depressed flat car, which is 6-axle, all right, go down a incline, and it's going to go faster when it's weighted than when it's not weighted. But there's an incline after the track, okay? And roughly, that car goes up just as far as the unweighted car. All right? And if you let an unmeasurable difference, let's put it that way, in all absolutes, etc., if you let them both run and you measured the stopping distance from the same point where the velocity is the same, the heavier car will stop first. All right? It's misleading because you see the car roll further, all right, because it's got more force being applied to it coming down the ramp. All right? But at the same speed, okay, if both were at 90, okay, coming down the ramp, you'll see in my demonstration, it's roughly, I think, 92, 93, if I remember correctly, scale miles per hour, unweighted. All right, it's 97, 98 miles per hour weighted. So there's a difference there. Now, if we move the track back to where it was at 92 to 97, you'll see the stopping distance for the heavier car would be less. Okay? Scale, turn on and tear it, which means level it out. Okay, so the the center truss flat car by itself weighs 2.5 ounces. Now if we add the Sherman tank, which is weighted so that it comes up to very close to NMRI standards, is 4.2 ounces. Okay? And all right, so here we are at the track I've set up, and it is approximately 7 feet long. All right, from over here down this incline. It's all spiked to it, through the AccuTrack to speedometer. Right. Then a level section here before it starts to climb back up. Right. We'll talk about all that here in a second. So let's we're going to do it. We're going to take 3 readings without a load and 3 readings with a load. And sure all axles are on. Okay. And granted, I don't have something that I can absolutely 100% equal, but we'll throw out any weird readings. All right. So here's first one without a load. And that's 91 scale, HO scale miles per hour. All right, 91. And if I would have been prepared properly, I would have had a pencil. Some paper. Okay. So, without a load, and with a load. So without, 91 is the first. Let's take it back. We're going to do 3. Throw out any oddballs. And that one's 94. 4. And 94 again. All right, so 91, 94, 94. Makes 93 miles per hour. Okay, let's add the weight to NMRA standard. $97. Not a whole lot of difference, but there is a difference. $95. And 97. So 90. I forgot. Okay, so there is a difference between the two. Added weight on a downhill grade will make it go faster. Why? Because there's more gravity there's more weight for the gravity to act on. Now, is that a good thing? Not so sure about that. All right. One thing I wanted you to notice, if you take a look over at the smokestack, okay? Take a look at that smokestack. All right. And you can go back and rewind if you want. But if you look at the weighted car, makes it there to the smokestack. Now, we're going to take the tank off and see. Now, what do you think? Is it going to go further or less? You can rewind it and look at it as many times as you want, but it goes the same distance. All right? Why is that? Why wouldn't the weighted car go further than the unweighted car? Well, the answer is you have gravity working against the rolling stock on an uphill grade. There's added friction. Now, why do we weight cars? Well, it creates that downward force, that 32 feet per second squared. Okay? That holds the car on the track better. It makes it roll faster downhill, right? But it creates drag, all right, equal to the increased force going downhill has an increase, but inverse force going uphill. All right. So instead of pushing that car down that incline, all right, down the decline, it is gonna hold it back going up an incline, which can be problematic. So it's not wise to overweight our cars. All right. There's detriments to doing it. The NMRI standards aim to hit that sweet spot where there's a balance between drag and rollability and holding the car down. Okay? That's what the NMRI standards attempt to hit, and it's pretty darn good. I'd be surprised if they didn't use an engineer or physicist to figure out the sweet spots. It's been too long for me to do that. But again, the key is, without a doubt, all things being equal, metal's going to be better than plastic. Okay? Metal axles, metal wheels are better than plastic axles, plastic wheels. In between, you got metal wheels, plastic wheels on a metal axle, or metal wheels on a plastic axle. Again, there's all different reiterations, but overall, metal wheel sets are better than plastic wheel sets as far as reducing drag, all right? Because there's less friction, because the coefficients of friction are reduced, okay? Anyway, hopefully that gets the message through to everybody, and you can do demos all you want, but science is science. Laws of physics haven't changed in hundreds of years. So with that, I want to thank you for joining me here at the Retirement Railroad Matinee Modeling Tip of the Day. Again, I'm Steve, and y'all have a great day. Bye now.